the wind tunnel revealed immediately the aero-criticalities of a project that was born old and unable to solve the downforce issues of the previous single-seater. Wide side pods compromise the floor efficiency, limiting the synergies with the rear wing and the diffuser for the purposes of ground effect. The flows don't interact with the low part of the single-seater, working as compartments only on the rear wing. The short conveyors of the old aero pattern reduce the air movement outwards, restricting the capacity to generate powerful whirls as a defense of the floor. The old SF23 pays a reduced downforce prevailing on the rear axle. The work conveys on the new downforce maps to rebalance the downforce to better distribute the load depending on tracks and setups, but always clashing with the old side pod's weaknesses. In Barcelona, the SF23 leaves the wide side pods characterized by a cooling system completely concentrated in the upper part. The heat outflow from the intakes enriches the flow over the side pods that, due to their end section raised shape, conveys the air on the rear wing, concentrating the downforce surge on the upper aero. But this solution exposes the single-seater to a higher drag compared to Red Bull's side pods that convey the flows downwards, generating a floor-protecting whirl, enhancing the ground effect. This moves the downforce center from the top to the bottom of the single-seater, improving the penetration coefficient. Also, the S-duct function changes by supporting the cooling system less, as it was previously arranged over the side pod, but powering the flow on the bodywork to the downforce advantage. The downforce increases, but the SF23 loses the balance restored with difficulty from Canada. Chassis and suspensions subjected to solicitations are adapted to the new downforce levels. To restore traction, Ferrari's engineers update the differential shafts, which are important to perfect the power distribution, the electric traction, and the support in acceleration. This is also advantageous in the corner when the car is in support. The torque is mostly of the outside wheel and it gives a steering effect to the single-seater. This factor reduces understeer and limits tyre tread sliding, avoiding tyre compound overheating. Distribution is optimized by power and it enables more elastic suspension settings, giving the opportunity to the less downforced internal wheel to copy the curbs, keeping the grip. The differential electronic control varies from the corners and forces acting on the single-seater in roll and pitch. This enables the optimization of the grip of the rear axle also in entry corner phase, with a downforce movement lightening the tyre support. In this transitory phase, the steered front wheels have to win the centrifugal force in order to direct the car, and the differential maps ease the processes, improving the driving precision that designs a faster, clean and flowing exit line. For the Hungarian GP, high temperatures require a precise aero setup to improve the cooling. Lengthened lateral grills and wider air intakes on the engine cover work in depression. The higher downforce aero has to increase the heat intake from side pods and radiators to peripheral devices which are delegated to drain the combustion chambers and heads temperature, reaching the most elevated thermal stresses. The hydraulic circuit, designed to work at a pressure of 2.5 pressure bar, raises to 120 degrees the boiling fluids, ensuring a reduction of the radiator's surface. More frequent charge and discharge cycles require an even more efficient cooling of the hybrid part, completing a reliability and performance picture of the Ferrari's power unit. The work mentioned by Ferrari's team principal is the last evolution step planned after the summer that will introduce corrective and ameliorative solutions to the rear end of the SF23, but also in anticipation of the 2024 single-seater.